Exponent Rules Part 4. So this is where we're going to talk about negative exponents. So when writing terms with negative exponents, they should always be written with positives, unless you're otherwise mentioned. So if you're solving a problem and it has a negative exponent in your answer, you need to rewrite it with the positive exponent unless it says specifically to keep that exponent negative. Okay? So for negative exponents, to turn a negative exponent into a positive exponent, the phrasing is to cross the line, that's my division bar, and change the sign of the exponent. So if I look at example 1, these are fairly simple. If I look at example 1, I have c to the negative 7th. So if it's not already a fraction, you can write it as a fraction. So the rule is to cross the line, so it needs to go into my denominator and change the sign of the exponent. So I'm now going to have c to the 7th, and it's going to have a numerator of 1. If there's not a numerator there, it needs to be placed there. Kind of like if I don't have a denominator for a fraction, it has to be a 1. If I take this piece and move it, that means I've taken it out, so I have nothing left, but I still need to put that 1 there, kind of as a placeholder. So if we look at example 2, my negative exponent is in the denominator, so I need to move it up to my numerator. So I would have b to the 3rd and change that sign to a positive. The value of your variable does not change. We're just changing the sign of the exponent. If you want to put it over 1, you can, but b to the 3rd is how you will see it written. If you look at example 3, they both have negative signs. So the x needs to go to my denominator and the y will need to come up to my numerator. So if the x is going into my denominator, that's going to be x and a positive 2. The y would go up, so y to the positive 3. And that's all that you can do. So now if we look at example 4, this kind of goes back to our same bases. When you multiply the same base, so they're both 4s, when you multiply them, the rule was to add their exponents. So if I have 4 and I have negative 5 plus a negative 3, that's going to give me 4 to the negative 8. But now I want to write it with a positive exponent. So I'm going to change it into a fraction because I know that this has to go into my denominator. So I'll have a 1 in my numerator because that's all that I'm going to have left. And I would have 4 to the 8th in my denominator. For example 5, same thing if we were talking about the quotient. So if you have the same base, c and c, if I have the same base, I'm going to subtract my exponents. So I have c and I have negative 5 minus a negative 7. So if I have two negatives, changes it to a positive. So I'm left with c minus 5 plus 7, which gives me c squared. So since this exponent is a positive, you don't need to change anything about that value. For the previous example, we had to change it into a fraction because it ended up with a negative exponent instead of a positive exponent. So that's the only time that you would need to change it at the end, is if you ended up with that negative exponent. If we look at example 6, has 1 over 9. So the question here is going to say something like, rewrite this fraction with an exponent other than 1. So exponent not equal to 1. Because remember, if there's a number there without the exponent, it's understood to be a 1. So I want you to rewrite this. So you need to figure out what times itself is going to give you a value of 9. So in this case, well, so if we had something like 5 times 5. So 5 squared is going to give me 25. This is kind of the process, the backwards process that they want. So what times what is going to give you 9? It's going to be 3 times 3. So I can rewrite this fraction as saying 1 over 3 squared, because 3 times 3 is going to give you that value of 9. Now, if they ask you to write it with a negative exponent, so if you have 3 squared in the denominator, it needs to go up to your numerator, and it's going to end up being 3 to the negative 2. So depending on what your question's asking you to solve for will determine how your final answer looks. And the last example over here, example 7, is 1/64. So again, it's the same like down here at number 6. They want you to figure out what times itself is going to get you to 64. In this case, you have a few different options. So if we start with our factor tree, we know that 8 times 8 is going to give you 64. So I could have 8 squared in my denominator. We also know that 64 is divisible by 4. That would give me 16. So now I have 1, 2, 3 4s in my denominator. And lastly, if I started with my 8s, I can break each of those down to 4 and 2. And I can break each of those 4s down into 2 2s. So I'd have 1, 2, 3, 4, 5, 6 2s also. So this 1/64, you have 1, 2, 3 different options that you can have. If I wrote these as negatives, it would be 8 to the negative 2, 4 to the negative 3, or 2 to the negative 6. So there's not always one right answer when solving problems like these.